Is my screen visible?
Yes, sir.
Okay, yeah. I think I asked some question in the previous session. Do you remember?
Yes, sir.
Yes, sir.
Yeah. Do you have answer for that question? List of molecules which are not recommended for pregnant women, and what's the reason for that?
Sir, trimethoprim.
Mm-hmm. So trimethoprim. Can you spell it?
TRIME
TRIME
THO
PHO
PRIM.
PRIM.
Yes, sir.
Okay. So who is answering?
Harini, sir.
Okay. So can you tell why?
Actually, it's used to treat for pneumonia and diarrhea, etc., sir. But it should not be
Mm-hmm.
used for a pregnant woman because it's very risky to consume this drug because it causes a neural tube defects, sir. It affects the brain development of
Okay.
developing baby.
Mm-hmm. What's the molecular weight of this molecule? What's the molecular weight? What is the log P of this drug molecule? Because in the last session we discussed about size of the molecule and the lipophilicity. It plays important role. Okay. So can you tell what's the molecular weight of this molecule and log P of this molecule?
290, sir. Molecule.
290. Okay. So log P is? So what is the log P for this molecule? Nandita. Anybody join with the name Nandita? மேடம் நீங்க எதாவது பேசுறீங்களா? I'm not able to hear anything from your Nisha. Nisha. You can unmute. Okay. What error, madam? Okay, so before attending the class, you should have a good microphone. It's a basic requirement. No, 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 I'm not here to get your answer through chat. Okay, just leave it. Uh, Sri Darshini, am I audible?
Yes, sir.
Sri Darshini, I'm not able to hear anything from your end. Uh, can you speak on your microphone? Varshita, anybody join with the name Varshita?
Yes, sir.
Yeah, yeah. Do you have any answer for my question? Yes. So in the last lecture, I have discussed that there are certain drug molecules which cannot be prescribed, which should not be prescribed for a pregnant woman. One main reason is the molecules can cross the placental barrier. So do you have any drug molecule which is not prescribed for pregnant ladies?
Pepto-Bismol.
Sorry, can you spell it? Can you spell the name of the drug molecule?
P-P-T-O.
P. Sorry, can you
P-E-P.
spell PAP?
P-E-P.
Can you type it on chat
Yes.
box? Yeah. Mm-hmm. Okay, what for this molecule is used? Can you tell what for this molecule is used?
For nausea, sir.
Hmm?
Nausea, tension.
Okay, why this molecule is not prescribed during pregnancy? What's the reason?
Side effects will be there, sir.
This is a very general, normal answer. No, you have to answer this scientifically. Side effects, any drug molecule will be having side effect. So why specifically this molecule is not prescribed for or during the pregnancy? I gave enough time for I don't know. Uh, okay, so let me check with others. So anybody with the name Harida? Harida. Okay, if you don't answer, I am going to remove from the class. Okay, I am so sorry to tell. There is no point of Santoshi Valli.
Yes, sir.
Yeah. Do you have any drug molecule with the reason? So can you tell the name of the drug molecule? You can unmute and you can
Sir,
tell
I
it.
have pasted in chat box, sir.
Okay, what for? So you can't read the name.
Yes, sir.
Can you read or not? Hmm?
Pseudoephedrine.
Okay, fine. So what for this drug molecule is used? Hmm?
Nasal conjunction.
Why this molecule is not
Sir,
prescribed during the pregnancy?
it shrinks the blood vessels, sir.
Mm-hmm. So what's the molecular? What's the mode of administration of this drug molecule? What is the mode of administration of this drug molecule?
Oral, sir.
Mm-hmm. So what's the molecular weight of this molecule? What is the molecular weight?
Sir, 201.69.
Mm-hmm. Okay. So Nandita,
Am I audible?
mm-hmm. You're not audible.
Am I audible, sir?
No, you are not. Is she audible to anyone?
No, sir.
Hmm. Okay, while coming for next class, you should have working microphone. You can mute your microphone. So anybody with the name Gautam Kumar?
Yes, sir.
Yeah, you have any answer for my question?
Sir, ibuprofen,
Mm-hmm. So what for this drug molecule is used?
anti-inflammatory drug.
Mm-hmm. Why it is not prescribed during pregnancy?
Sir, I don't know why it is not prescribed. I thought that it will cross the placental barrier. That's why only
You
it
should
will
not
not.
make guess. Okay, you have to read.
I assume that one and I didn't search it for that, sir.
Yeah, I understand. You have to search. Okay.
Yeah,
So
okay, sir.
while coming for the next class, you should have answer for that question. Okay.
Okay, sir.
So I'll ask you again that why this drug molecule, whatever you said, what's the reason for not prescribing during pregnancy? Okay.
Okay, sir.
Okay. So with that, we move to the. So where I stopped in the last class? I think this is this is where I stopped, right?
So volume of distribution.
Yeah. This we completed, right?
Yes, sir. We finished
Yes,
the
sir.
graph
Yeah.
first.
This also we completed. Okay. This and all we completed. Okay. Okay. The next is the biotransformation. Okay. Yeah. So as we know that we have completed what is absorption, what are the various factors that affects the absorption. We also discussed what is the distribution, what are the various factors which affects the distribution. So next is what is metabolism, what are the factors which affects the metabolism process, right? So metabolism is otherwise called as biotransformation. So as you know that we have two important types of physical process which going on. One is called as translocation process, another one is the transformation process. The absorption, distribution, and excretion. So these are the three parameters which are closely related to translocation of the molecules. And this metabolism, it's a kind of transformation process. So metabolism is otherwise called as biotransformation. Okay. So the definition already we discussed. Metabolism is the process by which the original drug molecule with its original structure will be converted into some other form with the help of some enzymes which are present within the cell. So mostly it's a kind of enzymatic conversion. Okay. So as per the textbook, the definition is the metabolic conversion of drug molecules to more water soluble metabolites that are more readily excreted. Okay. So many times I discussed that if you take any drug molecule, so the drug molecule should have balanced solubility between the water and the lipid. Okay, it should have both solubility in aqueous solvent as well as it should get soluble in the organic solvent. So water is an example for aqueous solvent, lipids example for organic solvent. But if you compare how much quantity of the drug molecule is soluble in aqueous and in organic solvent, definitely more amount of the drug molecule will get solubilized in the organic solvent comparing to aqueous, which means that the approved drug molecules will have more of non-polar characteristic comparing to the polar characteristic. More number of functional group will belongs to non-polar category than polar category, right? So why? Because that will help the drug molecule to get enter into the cell. Those molecules can easily cross the lipid bilayer, one of the major barrier for the drug molecule to get access into the cell. But after entering into the cell, after reaching the target site, after binding to the target site, after producing the biological response, the job of the drug molecule is over. The relationship is reversible. It is not irreversible. It's not permanent. So what will happen? The drug molecule will comes out of the drug target. Okay, then it leave the cell, and that molecule should come out of the body through the process called as excretion. Okay, if the molecule is highly non-polar, the molecule cannot get soluble in water easily and it cannot easily excrete it. So in order to make the non-polar compound into more polar compound, naturally this process called as biotransformation or metabolism is taking place in the body. Okay, during the process of biotransformation, there are three possibilities. The first is the original drug molecule can be converted into the corresponding inactive metabolites. Okay, which means that initially the drug molecule is in its active state, active form. So after the enzymatic conversion, after the metabolic conversion, which is converted into an inactive metabolite of metabolites. So the metabolites cannot produce the biological response. Second case is that the drug molecule after metabolism can be converted into active metabolites, which means that initially the drug molecule is in its active form. Even the metabolites of the drug molecules, they can also be active. They can also produce the biological response that is represented as active metabolites. So third case is the interesting thing called as a prodrug, which means that initially the drug molecule is used to taken in its inactive form. This is the only case in which the initial form of the drug molecule, the initial structure of the drug molecule is in its inactive form. So once if you take the drug molecule, once if the molecule enter into the cell, into the body, into the cell, so with the help of some enzyme, the molecule will be converted into the active form of the drug molecule. And the initial drug molecule of this is called as prodrug, which means that initially it is in its inactive state. So the next thing is that where the metabolism takes place, we already discussed about the first pass metabolism, if you remember. Okay, which mainly takes place in liver. But it is not necessary that the metabolism should takes place only in the liver. It can takes place in any organ, in any type of cell. Metabolism can takes place. So, but mainly it takes place in liver and some other organs or tissues in which mainly the metabolism takes place or gut. Okay, so some of the drug molecules can easily get metabolized in gut. Similarly, in kidney, the molecules can be metabolized. Some molecules may have the ability to get metabolized in the brain. It can metabolized in lung, skin. Okay, the message here is that it is not necessary that the drug molecule should be metabolized only in the liver, but we had to accept that liver is the major organ of which participate in detoxification mechanism. So most amount of the drug molecule will get metabolized only in the liver, but there are many other organs in which also the metabolism can takes place, like gut, kidney, brain, lung, and skin. Is it understandable?
Yes, sir.
Yes, right. So what's the role of biotransformation? Okay, so the ultimate aim of biotransformation is the body, the cell. If you take any foreign compound, or if any foreign element enter into the body, so immediately the body should sense it, and it should undergo the detoxification mechanism. Okay, that's the main reason why the biotransformation is taking place. Yeah. Okay, so this slide is very important for examination point. So here we have list of FDA approved drug molecule. So for example, if you take cortisone, it's a very commonly used drug molecule. So initially the drug molecule will be in its inactive state. So we can say that cortisone is a kind of prodrug. So initially, while taking this drug molecule, it will be in its inactive form. After the metabolic conversion, it is converted into hydrocortisone, and hydrocortisone is the active metabolite of cortisone. So this is the form of drug molecule which can go and interact with the drug target to produce the biological response. So we can say cortisone is the active form, and cortisone is the inactive form of the prodrug. So one more example is zidovudin, a very well known compound, which is an antiviral compound used for HIV. Zidovudin. Okay, even for some other viruses also we can use this molecule. So initially the molecule used to be present in its inactive state. While taking the drug molecule, the structure of the molecule is present in its inactive state. But after entering into the body, after entering into the cell, the molecule is converted into some other form with the help of certain enzymes. Okay, the enzyme which converts zidovudin into zidovudin triphosphate, which adds 3 phosphate group. And this is the molecule which go and bind to the corresponding drug target and produces the biological response. If you take morphine as an example, morphine is not a prodrug, which means that initially while taking the drug molecule, the structure is in its active form. So morphine is active. So one of the metabolite of morphine is morphine 6-glucuronide. And interestingly, morphine 6-glucuronide is also an active metabolite, which means that this molecule can also goes and bind to the drug target and it can produce the biological response. So similarly, diazepam. Okay, while taking the molecule is in its active form. The structure is in its active form. So after entering into the body, the enzyme which metabolizes this molecule into nordiazepam. Okay, so interestingly, this nordiazepam can also go and bind to the drug target to produce the biological response. Okay, so if you take paracetamol, we know that paracetamol is not in its prodrug form, it is in its active form, so which is an active drug molecule. So one of the metabolite of this paracetamol is N-acetyl parabenzoquinone imine. There are some other metabolites of paracetamol, right? So one metabolite is this, and interestingly, this molecule is toxic in nature. Okay, so which means that one another example is methoxyfluorine. Same thing. Initially, while taking the molecule, it is in its active form. It's an active drug molecule. So after the metabolism, what happens that it produces one of the metabolite as fluoride, and which is considered as toxic. Okay, so three cases. Again I repeat. First one is initially the drug molecule is in its active form. Metabolites are inactive form. So initially the drug molecule is in its active form. Metabolites are also in its active form. So initially the drug molecule is in its inactive form called as a prodrug. After metabolism, it is converted into drug. Is it understandable?
Yes, sir.
Okay. This different version of already what we discussed as first pass metabolism. I have more clear illustration for explaining the first pass metabolism. So the molecules, once if you take oral drug molecule, oral administration, right? So the gastrointestinal tract, GI tract. Okay, so the molecule can access the entire gastrointestinal tract. So some of the molecule which reaches the stomach. Okay, so it reaches the intestine. So this is the intestine part, and from there we have a hepatic portal vein. So the molecules enters into the hepatic portal vein. So this process is called as absorption. The movement of the molecule from this intestine region into kind of circulation, blood. Okay, this circulation is called as hepatic portal vein circulation. So it enter into the hepatic portal vein. So after entering into hepatic portal vein, the first organ to which the molecule reaches is the liver. So as we know that liver contains a major family of enzyme called as CYP, cytochrome P. Okay, the key player of detoxification process, key player in metabolizing the drug molecule. So what happens, after entering the liver, molecules will start undergoing the metabolism. Not entire, completely, not 100% metabolism will take place. Some quantity of the molecule without metabolizing will enter into the systemic circulation. Okay, the concentration of the drug molecule that is present in this systemic circulation, that is considered as the bioavailability. So already we discussed about the definition for bioavailability. The concentration of the drug molecule that is present in the systemic circulation. Okay, the systemic circulation is the circulation after liver. Is it understandable?
Yes, sir.
Yes, right. Okay. Any doubt up to this, I can answer if you have. You have any questions? You people can respond if you have. No, okay. So what are the different phases of biotransformation? We have actually, we can divide this biotransformation or metabolism into two phases. Phase 1 metabolism and phase 2 metabolism. Okay, so each phase 1 and phase 2 metabolic reactions are carried out with set of metabolic enzymes. Okay, So normally, generally, phase 1 enzymatic reactions which create or unmask a chemical group required for phase 2 reaction, which means that the process goes like first the drug molecule enter into phase 1 metabolism, or the phase 1, the enzymes which are involved in phase 1 metabolism, they prepare the drug molecule for phase 2 metabolism. Okay, but there are cases in which the drug molecule can bypass the phase 1 metabolism, can directly go to the phase 2 metabolism. Okay, so we will see what are the different types. Okay, this is a very simple example to understand the biotransformation process. So what are the chemical reactions which can takes place in phase 1 metabolism? Okay, so if we say phase 1 metabolism, then it can be oxidation reaction, or it can be hydroxylation reaction, can be a dealkylation reaction, can be deamination reaction, or it can be hydrolysis, right? So these are the major chemical reactions that can takes place at phase 1 metabolism. So here we have a drug molecule aspirin, the structure of aspirin. You have to remember for the examination point. Very simple structure. Is it a natural compound or synthetic compound? Aspirin. Mm-hmm. Am I audible?
Yes, sir.
See, if I ask some question, I am looking for some kind of response. Okay. Otherwise, there's no point of teaching. I don't know how many of you connected, how many of you know. I don't know what to say. I'm asking such a simple question.
Sir, it is synthetic derivative of natural substance.
Okay,
Cyclic.
you know the answer, but
Salicylic.
what hesitate? Okay, because we are going very slowly because I'm not getting response. If I get proper immediate response, I can I can accelerate the teaching. We can cover the syllabus at the earliest. Okay, this compound is not a natural compound. It's a kind of synthetic compound, and the starting material for this is a natural compound. Can you tell what is that?
Salicylic acid.
Salicylic acid, right? So salicylic acid is the starting material. Okay, that's fine. So can you make a wild guess? Whether this molecule will have more of water solubility or lipid solubility? Just you have to make a guess. You may not know the correct answer. That's fine. Hmm?
Lipids.
So what? Okay.
So actually, it must be water only, sir, because then only we'll be able to consume.
No, that's fine. That's fine. You have to first look at the structure, right? So if you look at the structure, first we have to classify the different functional group into polar and non-polar. Okay, so I am just splitting this structure into three major parts. So what is the nature of this part? Is it polar or non-polar?
Sir, OH group is there, so I think it will be
No,
polar.
no, no, no. I highlighted this. I am
Oh,
talking
this
about
one.
the
Okay.
arrow.
Sir,
Is it polar or
non-polar.
non-polar?
Non-polar.
Okay, this is a non-polar group. Okay, that's fine. So now moving to this, is it polar or non-polar?
Non-polar, sir.
Okay, this is non-polar. So what about this? COOH. What's the characteristic of this? Is it polar or non-polar functional group?
Polar.
Hmm? Okay, it's a kind of polar functional group. What about the COO? If you take this as a single COOCH3, if you take this, what's the functional group? RCOOR. RCOOR. Yeah. What's the name of this functional group?
Carboxyl.
Carboxyl, RCOOR. I already teach you one complete lecture on various functional group, if I remember. We discussed about from alcohol, ether, aldehyde. Huh? This
Yes,
is
sir.
ester, right? So it is ester. Is it polar functional group or non-polar? Hmm?
No, non-polar.
Polar, sir.
Two different answers. Okay,
Polar.
so certain atoms which are which are polar, certain atoms, if you take CH3 which is non-polar, right? Okay, coming to this, can we say that this molecule is having certain properties that is required for getting soluble in water, and it has certain properties which are required for getting soluble in lipids, because it is having both polar functional group and non-polar functional group. Do you agree?
Yes, sir.
Okay. So this drug molecule cannot easily soluble in water. Okay. So what happens is that this molecule undergoes a kind of chemical reaction with the help of enzymes, in which it is converted into. So this is one of the metabolite of aspirin. So it is called as salicylic acid. Now we have to compare the water solubility of aspirin and the water solubility of salicylic acid. So which one do you expect to have more water solubility?
Salicylic acid.
Salicylic acid. Why? Because
It
few
has
of the
two
non-polar functional groups which are removed.
carbon.
Am I right? Again, I repeat.
Yes, sir.
Few of the non-polar functional groups which are removed. So which turn this aspirin molecule into more water soluble. Do you agree? So what I'm trying to say is salicylic acid is more water soluble comparing to aspirin. Am I right?
Yes, sir.
So if I compare aspirin and salicylic acid, which of this molecule can easily excreted through urine? Aspirin or salicylic acid?
Salicylic acid.
So which of this molecule can easily enter into the cell? Aspirin or salicylic acid?
Aspirin.
Aspirin. Are you able to understand? For the entry of this molecule into the cell, okay, aspirin is preferred because it is having more number of non-polar functional group. But at the same time, the molecule cannot excrete it. It cannot get that easily completely soluble in water to get excreted through urine. So that's why the molecule is enzymatically converted into another form called as salicylic acid. So now, this is the product of phase 1. Now this molecule is taken to phase 2. Okay, so mainly the phase 2 reaction is the conjugation reaction. So the dictionary, meaning of conjugation, just adding. So if you have A and B, just add A to B. This is called as conjugation reaction. Okay, so here we should have OH, and this dotted circle is the salicylic acid, to which there are certain enzymes. We'll discuss about that later, right? So what it does is that they conjugate. They take some endogenous ligand molecule. Glucuronidine is an example for endogenous ligand molecule. It's a kind of sugar. Okay, it takes this sugar and attach. So we can say this is a carbohydrate. It takes the carbohydrate attached to the salicylic acid. So now comparing salicylic acid and this glucuronide, which one do you think is more water soluble? Comparing salicylic acid with this glucuronide form of salicylic acid, which one is more water soluble and why?
Sir, glucuronides.
Glucuronide is more water soluble. Why? Because we have more number of polar functional group. You have acid functional group COH. You have many numbers of the OH group. You have you have one oxygen in the ring. All this are polar functional group, which increases the water solubility of this salicylic acid derivative. Do you agree?
Yes, sir.
Yes, sir.
So now can we say that glucuronate form of the aspirin or glucuronate form of the salicylic acid, it can easily excreted through urine?
Yes, sir.
Sir.
Yeah. Can you now tell that why this biotransformation process is taking place? So can we say that biotransformation is the process in which the more lipid soluble drug molecule is enzymatically converted into more water soluble metabolites, which can easily excreted through urine?
Yes, sir.
Yes. Okay. So that is that's the definition for the biotransformation. That's what's clearly illustrated in this, right? So 2 points here. Remember, one is why metabolism is taking place, very clearly illustrated in this example. Second is what type of reactions that may takes place in the phase 1, and what type of reaction that may takes place in phase 2. So if we talk about phase 1 metabolic, biotransformation, oxidation, hydroxylation, dealkylation, deamination, hydrolysis, maybe some few more, right? So but these are the major 5 reactions that takes place at phase 1. The phase 1 reaction prepare the drug molecule for phase 2 by masking or converting certain functional group, right? So what are the major reactions that can take place in phase 2? The important reaction is the conjugation reaction. Any doubt up to this I can answer. Any doubt?
No, sir.
Okay, so I just stop here, right? So we'll continue in the next class. This week we don't have any internal assessment examination, CAE. Okay.
Yes, sir.
Yeah. Okay. Okay. Yeah. I just want to wind up. Yeah. Thank you.
Thank you, sir.
Yeah.
Yes, sir.